Welcome to the presentation of the Earth's atmosphere. I'm your instructor, Mrs. DeBose. Make sure you have a full heading on the piece of paper you have out in the upper right hand corner, first and last name, the period that you have science, and the date. Now, as we go over the Earth's layers, it's important to know that there are 5 of them. And today, instead of answering questions, I want you to take some notes. And for each layer that we're going to go over, I want you to get down 3 pieces of information. The first is the altitude. I want you to write down at what altitude above Earth's surface the layer begins and to what altitude above Earth's surface it extends to. The second piece of information I want you to get down is the temperature change within the layer. Does the temperature increase with altitude or does it decrease with altitude? The third piece of information is what you might find in that layer or an interesting characteristic of that layer. All right, so make sure you have your piece of paper ready, and let's get started. Know that many things in life come in layers. The atmosphere is one of them. Some of them you can eat, some you can't. All right, so we know that onions have layers and ogres have layers. We know that line from Shrek. And the Earth's atmosphere has layers, and each layer has its own distinct characteristics. The layers in order are the troposphere. That is the layer that is closest to Earth. The next is the stratosphere, then the mesosphere, the thermosphere, and the last layer, the closest to outer space, is the exosphere. So let's find out where these layers are located in relation to the Earth's surface and how they are affected by temperature. And it's important to note that this is indeed how the layers are separated, by how the temperature changes within them. Alright, so the troposphere is the lowest layer of the atmosphere. It's right next to Earth's surface. And this graphic shows that it goes from about 0 miles in altitude all the way up to about 10 miles in altitude. But we know that we like to think in SI measurements when we talk in science. So that really is from about 0 kilometers in altitude up to about 14 kilometers. The troposphere is where we live. It's the air that we breathe. So most of the air that makes up the atmosphere is found in the troposphere. So the troposphere extends from 0 kilometers in altitude all the way to about 14 kilometers in altitude, about 9 miles above Earth's surface. And this is where all the weather takes place for the most part. So your rainy days, plenty of those in Florida, to your snowy days, not so many of those in Florida. Sunny days, cloudy days, it's happening in the troposphere, the air we breathe. So in the troposphere, as you increase in altitude, the temperature decreases. And this is what you want to take a note on. In addition to the altitude being 0 kilometers extending up to about 14 kilometers away from Earth's surface, that's the altitude. You want to get this temperature change down. As you increase in altitude, the temperature decreases. And you might have noticed this if you've ever been up on top of a mountain, the fact that on top of that mountain is cooler up there than it was when you were at the bottom of the mountain. Also, if you've by any chance been up in a hot air balloon, you notice that it is cooler when you leave Earth's surface and up in that hot air balloon. Because you're getting further away, the temperature is decreasing. So at the top of that layer of the troposphere, it's about negative 60 degrees Celsius. That's pretty cold. And that's about, like we said, 14 kilometers away from Earth's surface. A hot air balloon doesn't go near that far up in the air. Stratosphere. That's the next layer away from Earth's surface. It begins at about 14 kilometers, which makes sense because that's where the troposphere ends. And it goes to about 50 kilometers away from Earth's surface. So as I have altitude from about 14 kilometers and to an altitude of about 50 kilometers away from Earth's surface. And we can see there that the stratosphere is in between the troposphere and the mesosphere. And the stratosphere is obviously much wider across than the troposphere. Now in the stratosphere, there's the opposite correlation than in the troposphere with temperature. We learned in the troposphere that as you increase in altitude, the temperature decreases. But in the stratosphere, as you move up in altitude, the temperature actually increases. Altitude increases in the stratosphere, and so does the temperature. So once again, the stratosphere. The stratosphere contains the ozone layer. Okay, the ozone layer is a layer of gas that absorbs solar radiation and releases it as heat to Earth, okay? And also in the ozone layer, harmful rays, those UV rays, are absorbed there. So this is why we always hear about the ozone layer and how important it is to us on Earth. And here's another depiction of that ozone layer and work, deflecting some of the sun's rays, absorbing some, and indeed some do make it to Earth's surface. The stratosphere, again, this is where the ozone layer is. The ozonosphere, as it's sometimes called, is towards the bottom of the stratosphere, and this is the illustration that simply shows that the ozone layer is not too far away from the troposphere. Now the next layer, the mesosphere, begins at an altitude of about 50 kilometers above Earth's surface and extends to an altitude of about 80 kilometers above Earth's surface. That mesosphere is right in between the stratosphere, and above the next layer we'll learn about the thermosphere. The mesosphere has the same temperature correlation as our troposphere. The further you go up in altitude, or the higher you go in altitude, the temperature decreases. And if you get towards the top of that mesosphere, you'll find the temperature there can get close to negative 90 degrees Celsius. Pretty cold. The mesosphere is also noted because this is where meteoroids burn up within the atmosphere. So the mesosphere protects the Earth. So we remember ME, mesosphere, ME, meteoroids. This is where they meet their end. Thermosphere is the next layer out from Earth. The thermosphere, the temperature rises there. It begins at an altitude of about 80 kilometers above Earth's surface and extends all the way up to about 600 kilometers above Earth's surface. A really, really large layer of our atmosphere. The thermosphere is next to the outermost layer of the Earth's atmosphere. And when you think of thermo, think thermometer. Think heat. In this layer, this is why it's called thermo. Hot, heat. The higher you go in the thermosphere, the temperature gets higher as well. So as altitude increases, temperature increases as well. And that temperature can reach as high as 1800 degrees Celsius. Now you know in science we're always talking SI measurement units, and that includes the metric system. But just to put in perspective for you, in Fahrenheit, because that's how we think in the States, it's about 3,300 degrees Fahrenheit. Pretty. Thermosphere is where you find the ionosphere. The ionosphere is found towards the bottom of the thermosphere, pretty close to that mesosphere. And this ionosphere contains electrically charged particles that sometimes can interfere with our radio waves that we like. So the thermosphere is where you would also find the aurora borealis, or the northern lights. And this is the result of the magnetosphere and how it interacts with the atmosphere and the thermosphere. And the magnetosphere contains electronically charged particles, just like the ionosphere, but they react in a certain way that creates those beautiful colors. The thermosphere is also where you would find the space shuttle. The exosphere. This is the outermost layer. Air molecules get so thin and far apart there that eventually you go high enough in the exosphere, they cease to exist at all. That's why there's no air in space. There's no clear boundary between the exosphere and outer space. So let's just say the exosphere begins at about 600 kilometers above Earth's surface and goes to an altitude of about 1,000 kilometers above Earth's surface. Now, when you're in the exosphere, the higher you go in altitude, the colder it gets. So in other words, as you increase in altitude, the temperature decreases, just like our troposphere. Alright, so here's a depiction of the 5 layers of our atmosphere. From the troposphere all the way to the exosphere, 0 kilometers in altitude all the way up to about 1,000 kilometers away from Earth's surface. Here's another graphic showing the layers of the atmosphere. And even one more. Onions have layers, ogres have layers. The Earth's atmosphere has layers. And each one has its own. Okay, so this pretty much sums up what we talked about during the presentation. So if there's any part that you're missing, any of those notes about the altitude, about the temperature change, or characteristic, what you find in that layer that you're missing, most of it can be found right here. These titles at top are searches you can do in your address bar across your internet, and you might be able to get to them. You should be able to get to them, and they have wonderful information about the atmosphere. One is, of course, a rap song. The other is an interesting little cartoon about the atmosphere. So if you have watched to this point, go ahead at the bottom of your notes and write the word coffee. Thanks so much, and make sure you turn in your homework tomorrow.